Morning, colleagues, and hopeful that you can hear me well. Am I heard from those ends? So for the last week,
Joseph, good morning. You are loud and clear.
last week on Monday, we tried to build a foundation that will help us write scripts in order for us to do data analysis or in climate science. And that way, we tried to understand the basic syntax, that is a building block as far as Python programming is concerned. And I'm convinced that if you have been practicing following each bit of this class, then we must be almost on the same page. So to recap, we were able to look at, last week we were able to have a better understanding of data structures, and we said they are the building block as far as computer programming is concerned, and writing good scripts also dealing with data. Because without the data structures, there is no way that you would store data within your application. We looked at things like the lists, and we get to learn how to initiate lists. We also looked at a dictionary, and we also learned how to deal with dictionaries, sets, and tuples, and ideal circumstances for each data sets, for each data structure. So today, we are going to look at the PANDAS. PANDAS is one of the powerful Python libraries because it's the foundation for data analysis. Through PANDAS, it is also a foundation for us to do what we call data cleaning, because most of the weather data is not that clean. You may find it with missing data sets that would affect your analysis. So this library is also good for exploring and manipulating big data, because as we know that each data that comes in climate science, data keeps on accumulating. And in order for us to have significant scenarios and studies, say for climate change, we need a longer period. So this library is very important in dealing with big data, so that we can make meaningful conclusions based on statistical theories. I've also spoke about cleaning the mess within our data. So this library is going to give us more like we deal with Excel. So we shall get all our data sets the way we had them in complex lists, which you don't like, complex dictionaries. We shall be converting it to pandas. And by converting it, we shall be able to manipulate with it in an interactive and interesting way. Doing things like correlations between two or more columns, calculating the average, calculating the maximum value, and so minimum values. Also deleting rows and columns that we don't wish to be within our data. So in order to do that, this pandas, as we said, it looks more like Excel. but we shall not be in Excel. Okay? Everybody that has ever used Excel. So it is going to get this data and convert it into a multi-dimensional table. And these tables, we shall call them data frames. And with data frames, you have columns and rows. To me, it's more like you are dealing with Excel. And it makes dealing with data more user-friendly. So let's begin. Hopefully you can all see the screen. So in order for us to use it, then we need to import the library. The library is called PANDAS, okay? And the way of importing it, we say import PANDAS as PD. This is just an align name. PD, that if I want to use it, I don't have to come and mention PANDAS. I'll just mention its ally, which is PD. Okay? But of course, it works along with other libraries that we are going to look at later. That is the NAP library that we are importing as NP. Also the matplotlib.pyplot as PLT. This is a library for drawing graphs. Okay, so after you importing this library into your Jupyter Notebook, into your working environment, then you can use this statement to get the version of the PANDAS that is installed on your machine. For my case, once I run this script, it has PANDAS version is 2.31. So in case you run and you are not successful, then you will have to install it. And in order to install it, you can open an empty cell and you type in this. Type install pandas, then it is going to install the library for you. And after that, you can use this statement to check the version that you have successfully installed the library. For my case, I already did. So this one can take you around 5 to 10 minutes or more, depending on the speed of your machine. So I'm commenting it out because I've already done it at my age, this machine. So now, after that, we can play around with the data structures that we talked about. In this case, I have a list, okay? And this is a list of value. If you can remember, this is a list. Wherever we have this type of brackets, okay? So that is a list. And when I come and say pd.series, so I'm going into the PANDAS library and I'm getting this value. And I'm getting the series functionality and I pass it to this data. That means now my list is going to be converted into a data series format. Still, if I come and say pd.series, it means I'm getting the series function from the PANDAS library. nap.array, I go to the nap library that is declared up, and I convert it into an array. So I'm getting it from the list to array, and finally into the PANDAS. Here, as we know, this is a dictionary. As you can see, this is a dictionary. This is what we looked at last time. This is a dictionary, and it is being named, this is from dictionary, and by me saying PD, this is PANDAS, that you go to the library, to the library called PANDAS and get the function series and pass this data from the dictionary. So what is appearing as what were the key values within the dictionary, they are going to be columns within the PANDAS. So you are going to practically see this. And once you print, this is what you have down. We got the first one was S list. And once we print it out, so we have data that is appearing in columns and rows. And we are going to look at this practically, and it is very interesting. So we looked at series as functions under PANDAS for us to get time series data. But there is also what we call data frames. Okay? Data frames, they are more usable. Why? Instead of having data in data series format, for the data frame, you're going to have it in columns. Okay? And that's what we are basically seeing somewhere. We shall see. So we get the data from the list to the dictionary. So we have the PD with data frame. So we are getting this function from the library, and we are passing over this as a dictionary. And how do you identify a dictionary? The data has key values. So it has the city as the key value for this, and then the data itself is Kampala. And then you have temperature as the key value, and then you have city, you have the value 28 as the temperature. Okay, and we say this is the first column and this is the second column. So once we pass this using the data frame function from the PANDAS library, then we are going to have a list of columns, and a list of rows, as we can see now. This is more understandable than the way we were printing the dictionary. Let me hope that is clear. So I've shared this Jupyter notebook. So you can practice, you can try to create a series of the last prime numbers just by following this function. Okay, so you have your list of prime numbers, then you use this functionality from PANDAS, you pass it to over and see whether you'll be able to have just a list of 5 prime numbers, first over series. And after that, you can create data frames for students with columns, ID, name, grade, and you're able to display the header and information. By doing this, you can pass this, the ID. You can make use of the dictionary by having the ID, name, grade as the key values in your dictionary, but these ones will later be columns after you turning it into the data frame. So that's it. Do you have any questions pertaining that? Is everything clear? So apart from reading data from dictionaries, getting data from lists, we can as well read data from Excel sheets, okay? That's what we call the CSV files. They are part of the Excel, but also Excel sheets, okay? Here I have a sample data sets, and as we can see, so PANDAS also has this library that is data range. So in this case, I'm defining data range, and I'm passing out the first value is date, and the period is 30. That means now Excel, I mean Pandas, is going to go and populate my data from 1st of January 2023 with period 30. That means we are going to have 30 columns and populate it with these data sets. If we are to make, as we can see, from here up to there, it is a list, and this list contains 30 elements as this. So this data, they are cells, and they are being passed over to regions. So you have another data key value, which are regions, and they are demarcated as east, west, north, south, and whatsoever. So the length of this list, okay, is equivalent to the length of this list. But as we can see here, this is a list, that is a list, is being passed over. But from here, the date, because we have key values, this is a dictionary. But we are being passed over to a pandas, PD, using this data frame. So here we get this data frame over here. We get the first data within our dictionary, which is a data frame, and it stops here. We take in the cells, which is a list, and then we take in the regions, which is also the list. So the total outcome is a data frame, and in order to achieve this, we have used the PANDAS library. So if we print this, this is what we are going to actually see. So let's run this first. Okay, and then, so you're able to see this kind of data. Instead of seeing it in a different format, then we are able to see it in columns and rows in a way that is more understandable, in the way that you really know things. It's more like Microsoft Excel, because you have rows and you have columns, and what were key values in the dictionary, now they turn into columns, okay? And what were lists here, they turn into rows, into columns. And these ones become column names or column labels. Is that clear? So that is one way, okay? So another way, because we have this data already reading in pandas, we can just come and say df/sample that get this data. We use the dot to pass off a function, a new function to this. So we are processing this data again, and we are writing it to an Excel sheet. So once I run this, then I have this data, okay, that is going to be converted now from my data frame into an Excel sheet. And this Excel sheet is going to be located within the same environment, within the same directory, within the same folder where you are working from. Okay, so this is what I've done basically. Here it is turning it to a CSV, but as well, we can have it in this Excel. CSV is also a format of Excel. We can have it this way, and in this case, it is going to convert it into Excel, which is the default is XLC sort of format. It is XL SX format. whereas here it is going to be in CSV format. So you find that most people are familiar when data is in this format, in either Excel format or CSV format. So this is another example similar to what we have, that once we have our Excel sheet already created, then we can read it. The way to do it, you are going to say pd.read/CSV, and this is the name of the file. Okay, sample cells.csv is the name of the file. And yeah, here you are able to read it. This key value is when you are reading the CSV file, and this .read Excel is when you are reading an Excel file. So I'm commenting out this because I've already formed these files, my computer. I'm also commenting out this to avoid overwriting. So after this, then we are able to read back and to get familiar. Here, when we say, this is text that is going to appear, but when we say CSV.df, which is the data that we read, CSV/df is our data that is already in the data frame. .header, okay, which is here, it is going to print for you the headers, okay, date, sales, region, okay, then Excel header, that's how it is going to read. And then when we come here and say header 3, which is this, it is going to go and correct the first 3 rows within your data. Are we together? Do you have any questions before I proceed? Is everything clear?
It's okay, but when you run those cells,
okay, yeah, the best way to practice this is to run and play around with these codes.
When you run those cells, gives an error.
You are running and you are getting an error? No, you don't.
You try to run from where you commented.
Now you make sure that you have imported the libraries. Make sure that you have PANDAS installed, DAP installed, Matplotlib installed, and OpenPyXL also installed. You may not do it now. Just follow, then later on you can practice on your own. So so we are able to read, we are able to get the headers, and we are able to go into particular rows within our data sets. Yes, so somebody is saying the error, yeah, please make sure when you see that I have these quotations here, it means my sample file is coming from the very directory or folder where I'm running this script from. In case it is not that, then you are going to put the URL, that is the address where your file is. Else you are going to run into problems. So as you learn, it is advised to be working from the environment where your script is running from. So now we have, so for here, we have our original. So in this case, now we are going to learn how to, I've gone through this. We are going to learn how do you deal, you can do things like data sort, okay? You can get data in ascending order, descending order, the way you would do it in Microsoft Excel, okay? So in this case, I have Excel/DF, which is my original data set. This is how it is. And when I sort it out, this is how it is going to appear. So the variables are going to be quite different. Okay, a minute, colleagues. All right, so in order for us to sort out this data, then the things are very easy. You call the data Excel/DFT because this data is already in pandas, okay? And we are using the DF, which is the data frame library, dot. And when I say sort values, I'm getting the function sort values from the data from the pandas library. And the syntax is we are going to use the keyword by equals to region. Region is a column within my data, okay? Okay, and by default, it is going to sort it by A to Z. A to Z, I think that is ascending order. So this is the same, Excel dot sort values by region. And in case I need descending order, that is from Z back to A, then I'm going to come and use the keyword ascending order equals to false. Then it is going to do it the other way around, which is Z to A. So it becomes very easy using these functions, okay? You just have to learn where these values, these functions do exist and use them the way they are. If it is sort/values, you're not going to write it as sort values from your head. Then that function is not there within the pandas library. But sort/values, that is what was written. And when we say by, okay, so I would want to sort my records by cells, for example. So I'm going to come and say sort by, so I'm going to put cells. And once I say ascending order, then we are going to have ascending means increasing. We are going to have the lowest cell on top and the highest down. And once we say descending, like here, then I have to change this into cells. Then I'm going to have it the maximum, the highest cell on top, and it's going to decrease downwards. Using the pandas library becomes also easy. So in your practice, you can try to practice using this, using that. So here we have here we are still sort by ascending order. This is descending order from Z to A. So this is similar to what we did up. All right, let's proceed. Let's proceed. This is the same. This is easy. We can group by using the group keyword, either by region and cells, sum. So in this case, it is going to go sum. Okay, if you want cells, then it is going to group it's going to get your cells, it sums them, then it groups by region. So it is going to get, say, get the whole totals for East, then it totals them for North, for South, for West. Okay? So in this case, you can also use multiple aggregations, that is by aggregating the total cells, the average sums, and the count. Then you come and you group multiple using this kind of code. Just go through this code, read, see the output, then you'll be able to understand them. For example, now you have total cells, average cells. The multiple aggregate word is going to deal, you are going to deal with more than one item at a time, okay, per group. So you have grouped by region and then dot aggregate, then you get the total cells. This is the keyword, and then cells and the term that you're going to use to calculate the cells, the mean, the count. So sum, mean, count, and others, they belong to the function, this function AGG within the PANDAS library. So it is the same here. You can go through this code during your free time and you get to understand. In this case, we are using the keyword for region, comma, group in grouped, okay? And the grouped are here. Excel, we grouped by region, okay? So printf region, then you're able to group our items. For example, I have East alone, North alone, and South alone. So we can do further data exploration. Yes, by reading, getting the header, practice this, describe what the data is doing, value counts, getting the unique values. Okay, so you're going to practice this, play around with the data set, and after playing around with the data sets, look at the outcome. In so doing, you're going to be mastering things. We can also do the data cleaning, as we said. We can fill in missing data sets. Okay, we can fill in missing data sets. We can rename. We can handle duplicates that are existing with our data sets. So in this case, at this level, I shared our DCADOC for July 2025, which is an Excel sheet, which I believe you all have, okay? So in this case, I'm using one of the columns. This is this combined DCADOC. When it is being saturated, it contains rainfall and temperature values. And what I did was separating it into two sheets. The first sheet has rainfall, and I named it rainfall, as you can open on what I shared on WhatsApp. And the second screen has temperature. So when I come and say df equals pd, this is pandas, please read Excel, read the Excel sheet, combine it. This is the name of the Excel sheet. And then the sheet name is called rainfall. The way it is, then it is going to return me data that is already converted into pandas data frame. So I know among my columns are stations. So we have the column that has station. So if I come and say station counts, that the data here that I have grouped by station, then it's going to go and count within data sets. How many columns do we have that contains the word Alua? Okay. How many do we have that contains the word Bikinyanya, Ulindi? So up to the last. Okay. This is our normal DCADOC reports that you people you are most well conversant with. So in this case, I can also count, print the number of counts using this, okay, by grouping by plus size. Okay, I have this size keyword. You shall get to understand the existing of these words. The more you practice, you get to understand which kind of functions that are existing within a particular library. So here when I come value count, it is the same. I'm counting the values within that. This is value count. Then it's going to numerically calculate the values within this column, which is stations. You will understand this more when you are practicing. So we have this. I can sort out a row by just saying that I have the Arua station, I have combined Decado / DEF, which is somewhere where I converted. Somewhere you will note as you are practicing where I read this file first. Where is it? It is here, but I must have named it somewhere where I converted it to DF. This is what it means. And then I'm passing it over the station, then value counts, then it is able to count. And when I come and say combined, Decado, July, DF, the one that I combined, okay, then I get the station. So by this way, I'm able to only look at values for Arua. As I said, that sheet, when you analyze it, it has both rainfall and temperature. So you'll be able to tell which values are temperature and which values are rainfall. So if you want to look at particular columns, it also has days. So I'm going to come here and say the columns. So for Carl in the station Arua, this word, we already have it here. I've already defined our station Arua, and that's what we are using it. And the in member operator is going to initiate the column, the variable called the Carl, and pass it, and it is going to pass it over values within the station Arua, and cross-checks each value if it contains in this. Okay, but in this case, to identify, because when I open that column, that sheet, I realized that the sheet contains many things, okay? But I'm only interested in columns that has the word day, okay? I'm not interested in totals. I'm not interested in rainy days. That is why I come and say, start switch day. Then it is going to capture any column name that begins with day. That's why I have day 1, day 2, day 3, up to day 31. Those are the monthly days. Okay, so now I have my first row. So if I'm to capture the first row, okay, if I say first, then it is going to bring out this, okay, which is day 1, 18, 16, and it continues up to the last item, okay? So this is very important because after converting this data as the way we can see, I can just come and plot it using the matplotlib library, which is part of the pyplot, okay? So, and I start by importing the library using the import value, then the name of the library, where I'm getting it, and then its ally name. Okay, and the day is equals to the first row, which I have here. Okay, and I pass it over as an index. Okay, and then values equals to the first row dot values, which is this. Okay, then I plot, then normal plotting, PLT, which is the ally name dot figure. Then it is going to have this then get and give the figure how big this our figure is going to be. Then the bar is a keyword that is going to define the kind of graph that we want. And this graph is taking days on the x-axis, whatever that we put here, it is going to be values on the x-axis, and values, and they are going to be values on the y-axis, and color equals to sky blue. It is going to be the color of our bars. Okay, it proceeds. X ticks, X rebels. How are you going to rebel? It is very important to have your y and x-axis rebel. So we have days, and in the x-axis we have rainfall. And then title is the title of the graph. It is rainfall distribution for July 2025. Title.layout. These are just functionalities that will help this graph to be drawn. And if you happen to draw it, this is what you're going to get. So in case you want to change this, you can just come here, iterate, and also get 0, because you have two columns. The first one is 0, and the second one is going to be 1. So able to get these values, also plot them, put the axes, pass values for the x-axis, pass values for the y-axis, pass labels for both the x-axis and the y-axis. Any questions? Any questions, people? Any questions? Do you have any question? Is everything clear? Is everything clear? Should we proceed? Annette. Have to Annette is here. Is everything clear? I'm just moving something very new, which is growing maps, and I wouldn't want to move alone. Is everything clear? You're only waiting for practicing.
Yes.
Katopo, is everything clear? Keeping quiet means really. Okay, who can say one word all to before I proceed? Who can summarize for us what we have covered so far? Who can summarize for us? Who can say what about the PANDAS library?
Everything is okay.
Yes, Kato? Who can summarize for
I've
us?
said this is not a tourism Makumbi, but the gadget they have has cut.
That what?
But so this Kumbi, this is Makumbi, but everything is going on well.
This is Obadiah on Kato's phone. So can Obadiah
PC at the office at NMC.
at NMC? Okay. So my question is, who can summarize for us? I want us to start something new. Is everything clear? Are you waiting for practicing, going through this Jupyter notebook? The difficult things we left them in week 1. Okay? That is when we left the most difficult things.
Yeah.
So, Annette, Annette,
Yes.
so can you say one word or two? You don't understand when you are alone. That's what I know. This is a math class. Programming is more like mathematics.
I joined late. I think I will try to follow afterwards.
Are the recorded classes useful? Are you making use of them?
Yes.
And one technique about programming, never try to cram a code. Never try to cram it. Just do things and finish. Just do code, understand it, it's doing what you want. You leave it at that. Never struggle yourself to cram the codes. Even me, I don't know. Because most of the time when I'm coding, I also use internet. You look in and there for tools to use, because there is a lot. When you try to put everything in your head, it may become difficult. But the more you play around with the code, the more you get to understand the jargons, okay, that you can use to play around with data. And that is something that is very important. So that is how we draw graphs, okay? And I would expect you from here, you can go and use different tools that are available online to play around with the data, okay? To try to uncover those things. You are the guys in operations. You know the kind of things that you want to see from your data. You try to use Python, okay? You go on Google and try to check and see what are those things that I can uncover from this data, then see whether Python can do it for you. Okay? Read the code, understand it. If you don't understand it, ask. Okay? Before you struggle to write your own code. You can try by looking at codes that have been written by others. Okay?
Okay.
So let's go to how to use the GeoPandas. The GeoPandas is a library. The GeoPandas is a library that will help us draw graphs. And in this case, in order to draw these graphs for today, we need what we call sharp files. For people that have dealt with GIS, you have come across sharp files. Sharp files are everywhere. These are files that you can use that can help you identify regions. After identifying regions, then on top, you're able to put your data. One of the sharp files that I downloaded is .ug.sharp. That one has the district boundaries for Uganda. And my purpose was to get this file. And after getting this file, then I'm able to use it to have my data on top of it. And yeah, we know this technical keyword. So we come and say sharp file path equals to UG sharp, meaning my sharp file is contained within the directory where this script is running. And Uganda equals to GPT, which is the geo PANDAS library that is going to read the sharp file path. And when I come and say Uganda header, now this functionality is going to read me the details of this file. So this file has columns, ID, name, and source. So in case I want any particular region, we shall say name equals to Abima. Then I'm able to get that district of Abima. Name equals to Agongo. So these are administrative boundaries for Uganda that are contained within this shapefile. They are accompanied with latitude and longitude, okay, boundaries. So if I come and say ug.columns, then I'm getting the columns. So it has ID, name, source, geometry, okay? So in this case, now I start scripting. So we have import GeoPandas as GPT. I'm importing this library because I know I'm going to draw graphs. Import matplotlib.pyplot. I know this is what I would use if I want to plot anything, to do plotting, either on the graph or on the map. And then from sharply.geometry import point, okay, I put this library is relevant because I'm dealing with sharp files, and I'll be getting the geometry points, which are the longitude and the latitude and the longitudes, okay? And I'll be plotting points on the map. Also import NAP as NP. So we shall look in details, I think by the other week, we shall be looking at the NAP library in details. So it all begins. So in this case, I'm interested in getting Alua. So I go and who can tell us which data type is this? Is it a set? Is it a tuple? Is it a list or a dictionary? Which data set is this? Which data structure is that? Who can tell us? Dale. Which data type uses those kind of brackets, this and that? Which data sets? Which data sets uses those kind of columns? Who can tell from last week class?
Etapo.
Yes, and why are we using it in here? Why are we using that? What are its characteristics? It cannot allow. What is the first characteristic?
It is immutable.
Hmm? It is
Ordered and immutable.
And it is immutable. So you cannot change its values. What else? So you will find that in order for me, it becomes easier for me to define tuples when I'm declaring coordinates of a particular region. And this is going to be very common in most climate that you are going to come across. Coordinates will be defined as tuples. That you are going to see. So you have longitude and latitudes. And here we are, rainfall mean. We get the first row. This is some data that I have up. First row, okay, dot mean, that I'm going to calculate the mean rainfall. And that is the first row within my climate data set. Let me try to get it. Let me try to see whether I can get it here. Huh? I think I can get it here. I can understand it here. Well, yeah. So we have raw rainfall. Yeah, it is some value that I defined somewhere. Shall follow within the data somewhere. Cannot be here. I think somewhere when it is here, row 1, and we have been able to get these values. Okay, that is why I'm referring to it here. That's where it comes from. So load Uganda sharp files. So Uganda equals this one we know. The library is gpt.read file uki sharp. So you can replace this with your own sharp file, the way you have named it. So create a rainfall column for shading all districts. Okay, while we are going to ignore the NNA values within our data set. So you are going to say Uganda rainfall, that is going to be the column. NAP, we are using NP, we are getting the NAP library, and we are telling it to deal with the NA values. And then here when we say Uganda.log, Uganda name, this name is coming from the shape files, okay? And we are getting Arua, okay? And we are passing it over rainfall, and we are passing over rainfall mean, the one that we calculated, okay? And after that, it becomes very easy. So we are going to plot So the column is going to be the rainfall value that we have. Okay. The labels, it is going to be rainfall in millimeters. So we can add the plot that we are going to use to be read. We are going to add the location name and rainfall value using this graph. Okay. Title is the title of the graph, rainfall in Uganda, Arua. And then on the x-axis, we have the latitude on the y-axis and the longitude on the x-axis to be able to allocate this place. So in this case, we are able to follow this code. You'll play around with this code. After understanding it, you try to pass over values. You try to change the locations, okay? But these names have to be identical with what you have here in your shapefile. So we have been able, then the title, we know where to get it, okay? The axes on the key, we know where to get them, okay? Then the plot, which is red. And finally, you have this map. So you may have received maybe a customer that is only interested in knowing the rainfall distribution within a particular region. So instead of giving the whole map, say for Uganda, you are able to zero down, okay? And if you have several data sets, we have learned, we can get these data sets, convert it into pandas, and then you are able to have it on your graph, okay? And then you are able to serve your client more satisfactory. Any question on this? Do you have any questions? Obadia, is this helpful for your operations? Is this something that is helpful for us? Let us try to have these classes interactive, because I'm beginning to tackle scripts that are ideal for our operations, that we are going to be Somebody is saying, I was suggesting if we reach a practical session, it is better for everyone to be doing. This is what I'm expecting. But Obadia, we are on different levels. Some people are trying. I don't know whether you are trying or not. But I sent these scripts early enough from yesterday. I've been sharing information. I would expect at this level for us to be more engaging, because it is through being more engaging that we are going to learn. Because something that I would take too obvious can turn out to be something very difficult for you, and it may stop you from learning. Okay? And I'm asking you, just say a word or two. What is your take on this? Mike, are you with us?
Yes, I'm with you.
So can you ask anything as far as this work is? Do you have any questions? So if I tell you to get this and we pass on temperature, are we able to do it? To get temperature from our decadals and we plot it on a graph. Or if I tell you to get data for Mubende, or Mitiana, or another station, or Entebbe, Obadia, are you able to plot for us the data for Entebbe only from our decadal? What about Israel? Israel, you are so quiet. So who can promise me that the next class is going to plot the graph for Entebbe? So I want to assign ourselves tasks. One group is going to do Entebbe graph. Another group is going to do Kampala. Another group is going to do Damulonge. Another group is going to do Masindi. We have a number of weather stations when we check. So in the chart, who's doing Kampala? Who's going to try out the graph for Kampala? Who's going to try out the graph for Entebbe? The NMC team, let's do the graph for Entebbe. Whoever works from NMC. And then the Kampala team, let us do, let me first read the charts. The NMC are going to do, I shared the Excel sheet. You can do a basing on that. The Decatur, let's do Entebbe. And we are doing the average rainfall. The average rainfall, that means you are going to get that day, then you convert it into the mean rainfall, and then you're able to put it on the graph. Is that clear? So next week, I expect people from NMC. They are going to present to us the graph for Entebbe weather station. And these people are going to be led by Obadia. The Edicoca team, they are going to be led by Jack Arnett. And they are going to do for us the graph for Kampala. And that's it. We shall have two graphs. And you are going to deal with both rainfall and temperature. And to give you a hint on how you are going to do it, it is very easy. Just come here and say station equals to Kampala. Okay? The rest is going to be done. The rest is going to be done. So change here, put Kampala, and make sure that the name that you put here, it is how it is existing within your data sets. For example, here at the station, let me look for Kampala. Kampala is here. So just copy and paste and replace it here. Proceed, change, then the name that you would use here here has to be the name the way it appears in your sharp files. That's the only thing that you need to do. The rest, run and get to understand how, whether you're able to come up with this graph. So next, we are going to try to bring it all together, okay? So we are going to get this data for each station, okay? And we plot it on a single Uganda map. This is a single Uganda map. If we are to add the boundaries, this is a single Uganda map, okay? And we have the first, it is going to read our data. Okay, this is reading the data from the Excel sheet. It is getting it from rainfall sheet, okay? And we have gone through this. We have gone through this, and we said we know how to use the for loop. So column, for column, data, dot columns. The purpose for this is to, Michael, if you don't mind, can you mute? I've mute you. So we are going to go and get those columns that are beginning with day. Okay. And we have the day columns. Okay. And then we go and calculate the mean rainfall for each of the day columns. Okay. We are going to convert coordinates into numerical and drop invalid rows. Okay, so when you check the data, the columns for latitude and longitude, some values were not well entered, and for us to be on the safer side, we are commanding the script to ignore such values. Okay, where the data is invalid. So next is we are going to load the Uganda Sharp files districts, okay? And we are getting it, we are reading the file, which is ug.shape, okay? And the comment here is replaced with your Sharp file. So you can go on internet and get better Sharp files, and you come up with a better map than what I have, okay? So assign rainfall to districts. So we are going to go into the GPT. So here we are getting districts from our earlier acquire, because we are using GPT Geo data frame. We are converting it to data frame.